So, good evening, everyone. I'm Nishant Tiwari, part of data science team in Analytics Vidya, and I welcome you all to our data session. For those who are attending this session for the first time, let me give you a brief introduction. What data is? Data is a 1 hour dedicated session where we learn about the emerging technologies and topics related to the data science field. For today's session, we are going to talk about the key steps for designing convolutional neural network for image classification. What CNN or convolutional neural network is, like, it's a specifically used for processing the image pixels. Okay, so before we move on to the session, just let me give you a quick recap for the instructions. We are recording this session, and this recording will be available on our YouTube channel. You can find the link for the channel in the chat section. And please ask your questions in Q&A section, and we'll be taking on those questions like in mid session or at the end of the session. Lastly, we are sharing some polls, so please do fill those polls because that will be really helpful for us. Now, for this today's session, we have Arpit with us. He's an international speaker in the field of DS, ML, BI, and AI, and is currently working with INFOSE as a senior data scientist. He has an experience of 11 plus years in VLSI research and data science, machine learning, and artificial intelligence. So I'll just pass on the stage to the Arpit, and Arpit, you can share your screen.
Yeah. Thank you very much for your kind introduction. Also allow to share my video as well, if possible.
Okay, I'll just see to it.
Also, please make me co-host if possible. Yeah.
You are co-hosting already.
Okay. Thank you very much. Tell me my screen is visible. Hello. Yeah, am I audible or not?
I think it's a network issue, but your screen is visible and you are audible. Please, Arpit, can you check your internet connection once? Now your screen is visible. Participants, please wait for a few minutes. Just give me 1 or 2 minutes. I'll check what is happening. I think there is some technological issue. We'll start in few minutes. Just be there with us.
Hello. Hello.
Yes, sir, Pit, you are audible. You can share your screen
Yeah,
and
yeah. Just give me a second. I'm sharing my screen.
Thank you everyone for having patience. We'll just start in a minute.
Just give me a time because I'm automatically getting disconnected from the session. Hello, Sagar. Can you please able to tell me my screen is visible now? Hello.
Yes, your screen is visible. You can share. You
Yeah,
can start.
and my voice is clearly audible.
Yeah.
Thank you very much. I'm starting my session. Thank you, Sagar. A very good evening to one and all. I welcome all of you on our today's session called Key Steps for Designing the Neural Network. The participant, actually, this is my third talk series. Before that, I have already delivered the two talk. First talk, I have delivered that key step for designing the artificial neural network. Then after that, again, I have delivered the second talk on how we are using the artificial neural network for image classification. And now this is a third talk, which I am giving on key steps for designing the convolutional neural network. I request all the participants for the clear understanding. If you will go through my previous few talks, that is two talks which I have delivered, then you will understand a very good way this session. So in my today's session, I am going to discuss about the main important concepts of convolutional neural network and how it is useful in our day-to-day life. Before moving, I would like to say things to all of you. Architectures are available for the convolutional neural network. Important question is that going to what are the
Arpit, can you check your internet connection once because your voice is breaking? Uh, I think there is some disturbance from Arpit's side. Let's wait for him, and we'll continue this session. Sorry, guys, for this disturbance. We'll continue this session, and let's wait for Arpit. He's having some internet issues.
Saga, hello.
Yes, Arpit, Nishant here.
I'm getting lots of disturbance actually. Automatically, I'm getting disconnected. I really don't know why. I'm trying my level best to solve, but again, I got Sorry, I got connected now. So let's start the session. I don't know why I'm disconnecting.
Okay, you can continue.
Yeah. Just give me a moment. I'm just going to share my screen. Now, can you please confirm, Sagar, my screen is visible?
Yes, your screen is visible.
Okay, thank you very much. Okay. So I'm starting. Sorry for disturbance, guys. Sorry for all the inconvenience. So I'm starting my session again. I welcome all of you for our today's session called Key Steps for Designing the Convolutional Neural Network. And I'm going to guide you all the key steps for that. So before beginning the session, I would like to say something about me. My name is Arpit Yadav, and I'm working as a senior data scientist at INSOFE, Bangalore. Other than that, I'm associated as a mentor with multiple companies and universities across the India, where I'm working as a CTO at AI Beehive Bangalore. I'm also working as a guest faculty in artificial intelligence and machine learning at BITS Pilani. I'm working as a mentor in AI/ML program at IIT Guwahati. Other than that, I'm associated as a mentor with multiple university for designing the AI/ML process. Now, about my education qualification, I did my bachelor's in electronics and telecommunication engineering and master's in VLSI design. I did my PGP in artificial intelligence and machine learning from Texas University, USA. And I'm currently pursuing my PhD in machine learning in the field of deep neural network only. I'm having the total 12 years of experience. Parallelly, along with my main job, I'm having the 8 years of experience into the skill development training. I'm an international speaker in the field of data science, machine learning, deep learning, and AI. I have filed 4 patents till date in the field of artificial intelligence and machine learning, and I have published so many international journal publications as well. I did 70 plus certification in the field of AI. Whatever the small contribution I have given to my field, I have been rewarded with these 4 awards, which motivates me a lot to do something better for the society. In that, I received the award as an Inspirational Data Scientist Award for AI/ML work only. And then again, I have received the Excellence Research Award by the Progress Global Foundation for some paper publications. Then I have been awarded as a Best Corporate Trainer Award and the Best in Innovation Training and Design Award. So these are all awards which motivates me a lot to do something better for the society. So let's go ahead for designing the main concept today, that is called as a convolutional neural network. But before moving ahead, whenever we are doing any projects in the field of deep neural network, this is a motivation slide for all of us. In this slide, with the help of this equation, we are solving the n number of projects in the industry. So what this slide tells about? This slide tells about that the heading of this slide is new normal in the technology, guys. New normal in the technology. What is the exact meaning of new normal in the technology? First of all, let's understand the meaning of new normal. The meaning of new normal is very easy. New normal means what? Anything which is coming new to the world and becoming normal very easily is a new normal technology or a new normal concept. In the technological world, new normal means what? For example, artificial intelligence technology is a new normal technology. Why it is called as a new normal technology? Because in this new normal, artificial intelligence is very new to the world and become very normal easily in the field of many applications. Because of this reason, many industries are using the artificial intelligence, and it is a new normal in the technology. So to understand that, in this slide there is one equation is written. Let's understand the meaning of this equation. Very simple. Whenever we are adding data science, machine learning, deep learning, and artificial intelligence to any X, we are always going to get a profit and the growth, guys. Okay. So again, I need to ask the audience, from your end, what do you think about, what do you mean by X about? What do you think, guys? What do you mean by X in this slide? Any answer for that? Industry. Okay, very good. Bala has given the correct answer, industry. X means any industry. For example, you put healthcare industry in place of X. So you are always going to get the profit and growth there. How? In the healthcare industry, we are making n number of applications with the help of artificial intelligence technology. For example, you people are going to make a robots which are going to do surgery, that is called as a robotic surgery. You can make n number of apps with the help of AI technology to detect the deadly diseases in advance, so that you can save the life of people. You can put banking industry in place of X. You can make so many applications with the help of AI technology, whether to give the loan or not to the person. Okay, we can identify the defaulters in the bank industry with the help of AI technology. So that industry in the world of data science and machine learning is called as a domain. We are using the word as a domain to them. Hence that equation will become, adding data science, machine learning, deep learning, and AI to any domain, you are always going to get business and profit. Hence, to make any successful project in the world of data science, machine learning, deep learning, and AI, there are two important knowledge required. One knowledge is called as a technical knowledge related to the field of data science, machine learning, deep learning, and AI. And the second important knowledge required is a domain knowledge, in which industry and in which process you are going to apply that knowledge. So domain means industry knowledge. For example, suppose I am working on the project called as cancer detection using machine learning algorithm. So cancer is a healthcare domain, and I am a non-healthcare person. I am an engineer. I didn't know a bit about cancer. So I cannot able to solve this project without understanding the cancer knowledge, or we can say a domain knowledge. Hence, we are taking the help of domain expert in the industry, and then whatever knowledge I am having in the field of AI, and with the help of domain expert, we both are solving that projects. So remember, guys, very crucial, domain expertise is extremely important in the field of AI ML technology to solve the project. If you are not having the domain knowledge of that part, so once it is there, then we are going ahead for the further part. So please concentrate. This is called as a roadmap to learn the deep learning technology, guys. And as I said, please attend my two previous sessions. I think that you can contact Analytics Vidya only for the link of my previous two sessions. In that, this roadmap I have discussed about. And if you are very newcomer in the field of deep learning, please follow this roadmap blindly, because this roadmap is the step-wise direction to learn the field of deep learning. In that, it is said that first of all, you need to understand the biological neuron working. Biological, that means I'm talking about biology subject. We need to understand the biological neuron, because our entire deep learning world get inspired or motivated from biological neuron only. Scientists has taken the inspiration from that, and they have made the first world artificial neuron, that is called as the perceptron of the world. After understanding the working of perceptron, you people will came to know the three important things or terminology inside the perceptron, that is called as a weight, bias, and activation function. Due to the time limitation, I cannot go in detail about that. I have already discussed this in my previous talk series. So please go to understand weight, bias, and activation function. But there are certain limitations of perceptron. For example, logically, I am asking to you question. Please tell me, everyone, in our human body, there are billions of biological neuron available. Billions of biological neuron, from where the scientist has taken the inspiration to make an artificial neuron. So my body right now, in my body, all the biological neurons are communicating in such a way that I am giving the talk to you people. Similarly, all the biological neuron in your body is communicating in such a way that you are listening to me. So one simple question I am asking, does if in my body only one biological neuron is present, will my body will function or not? Tell me the answer. Or your body will function or not? Only one biological neuron. No, one biological neuron not able to function our body. Hence, we required the billions of biological neurons, out of which good biological neurons are getting connected with each other to perform some task. Same in the world of artificial neural network, single perceptron is not sufficient to solve the complex problem. That is called as a non-linear problem. Perceptron is a linear classifier. Hence, in order to solve the non-linear problem or complex problem in the field of deep learning, we are using the multi-layer perceptron, that is also called as artificial neural network. So artificial neural network, I have already discussed in my previous talk. So please go ahead and watch that. So artificial neural network is working in the two methodology, guys. That is called as forward propagation and backward propagation. Forward propagation is used for prediction. That predicted value we are comparing with actual value. We are getting the error. So to reduce the error, we people are doing the backward propagation, and during the backward propagation, optimizers are used in the field of deep learning. So that understand all optimizer. One of the optimizer is a gradient descent, then stochastic gradient descent, ADAM, ADAGRAD, RMS prop, and so on. Understand that. After that, we will come to know how to design the ANN with the help of sequential and functional API. There are two kinds of designing in that. I have already discussed in detail that. Now today, as we are moving ahead, step-by-step process for the further designing of deep learning architecture. So again, guys, ANN is having certain drawbacks. Artificial neural network is having certain drawbacks, which is overcome by the other part. So the thing is that in this roadmap, after ANN, artificial neural network having certain drawbacks, which is overcome by other architectures. So what are those other architectures? So other architecture is called as, for example, CNN architectures, which is specifically designed for handling images and video kind of data. And a field which is related to images and video kind of data is called as a computer vision. So CNN is the basic architecture for that CNN for the computer vision field, and other architectures are available. I will guide that. Don't worry about that. Other architecture is called as the RNN, recurrent neural network, which is specifically designed for natural language processing problems, sequential data analysis. So there are also other architectures available called RNN, LSTM, bidirectional LSTM, transformer, BERT, GPT-3, and so on. And again, after that, there are more architecture designed for a specific application, that is called as a GAN, and so on. So what I mean to say that please follow this guideline, please this step-by-step procedure in order to understand the real world of deep learning. You will really enjoy that, and then do the small project, do the small case study by understanding all the concept mathematically. So let's go ahead. As I said you, when we are going for CNN, so ANN is having certain drawbacks. So what are those drawbacks, guys? Artificial neural network designing is based on fully connected layer fashions. If you go through learn the ANN designing, it is having the fully connected layer fashion. Due to that reason, we require the more computational systems to perform the computational mathematics inside that. So for that process only, we required more hardware dependency on the ANN. There is no parameter sharing inside the ANN architecture. ANN architecture is not work good on image data and the sequential data. Why? Because I will let you know what is the major problem of that. So artificial neural network is not working good on unstructured data, that is images and video. Okay. Although if you try to work on artificial neural network with images and video, it will give the output, but it will be not optimum output as compared to other architecture. So that is a meaning that we are having the certain limitation for ANN, and that limitation is then overcome by other architecture. And in the deep learning world, that application for the other architecture is called as this. One application is called as the computer vision application. One application is called as a natural language processing application. One is called as the GAN. So in the computer vision application, what we are doing, we are giving the ability to computer or the systems to visualize our real world in terms of images and video. And from that, they are understanding something from that images and video to give certain outcomes. Similarly, in the natural language processing, what is going on? We are giving the ability to computers and the systems to understand, read human languages, interpret something from that, and give the outcome accordingly. So that is the main process. So in this part, actually, these are the use cases of the deep learning, major use cases of the deep learning, computer vision and natural language processing, and so on. As I said, for the computer vision application, researcher has made intentionally one architecture. That architecture, basic architecture, is called as convolutional neural network, which is specifically, as I said, designed for images and video. And there are other applications in the field of computer vision that I'm going to guide you. So which architectures are used for that, that also you should know. So in the field of computer vision, image-based applications are majorly used. Video is nothing but the sequence of images only, and so on. So concentrate carefully what I am guiding. In the field of computer vision, we are having so many applications such as image classification, image segmentation, object detection, GAN, and so on. So whatever the application we people are having in the field of computer vision, we are having the special architecture designed for that. You don't need to design the architecture. If you want to design the architecture, that is the research part, then you design your own architecture. But the technology advancement has been taken place in such a fast speed that whatever the application you people are going to work for computer vision, already ready-made architecture available in the market. For example, as I said, image classification is one of the application in the field of computer vision. So we are having the basic architecture called as convolutional neural network for image processing. Other than that, also there is concept called as transfer learning. Transfer learning means what? There is one competition in the world that is called as the ImageNet competition, and the winners of that ImageNet competition is declared as a state-of-art algorithms or state-of-art architecture, and that architecture is again useful for the image classification based problem. Again, other application in the field of computer vision is image segmentation. Again, there are predefined architectures available. For example, RCNN, fast RCNN, faster RCNN, unit. This architecture is specifically designed to solve the problem of image segmentation. Other than that, third major application is called as the object detection in the field of computer vision. For object detection also, there are many architectures available in the market, but the famous one is SSD, for example, single shot detector, YOLO and its version. And the last application in the field of computer vision is called as the GAN, Generative Adversarial Network Unsupervised Learning. So the what I mean to say that there are many applications, just I am highlighting the major one. So in the field of computer vision, for these four major application, image classification, image segmentation, object detection, GAN, major architecture has already given by researcher to us. So all this architecture fundamental is that these all architecture are born from CNN. This is the major part. That's what today's heading is: key steps for designing convolutional neural network. All this architecture, if you will go through after my talk, you will find that this architecture is nothing but CNN only, convolutional neural network, and so on. So the thing is that today major motivation is to learn CNN architectures. That's what we people are learning CNN, because entire computer vision applications depend on CNN. So in the CNN, today we are going to learn about what are the key steps to understand the CNN and so on. And I'm going to guide you in a very easy way. So please concentrate carefully. Convolutional neural network is nothing but one ANN only, artificial neural network. Only the key difference is that in the artificial neural network, we are having the structure, input layer, hidden layer, output layer. As in the convolutional neural network, we are changing the entire hidden layer architecture. And this is our hidden layers in the field of convolutional neural network. Convolutional neural network having the four major layers. We can say majorly three. That is convolutional followed by non-linearity activation function called ReLU. So the first layer in the field of convolutional neural network is convolutional layer itself. Second layer is called as the pooling layer or subsampling layer. And the third layer is called as the fully connected layer. What is the basic need of all this layer that I'm going to guide you in the high end? Don't worry. So just remember that foundation of convolutional neural network is these three major layer: convolutional followed by ReLU. This is one layer. Second is called as a pooling and subsampling, and the third is a fully connected layer. So for what purpose all these three layers use and what is going on inside that, let's understand that. And why the name convolutional neural network has been given the name convolutional, that depends on convolutional operation only. So let's take it. So please concentrate guys in this slide. I have given one image for some certain task, that is image classification, for example. So how this image will pre-process from input layer to output layer, and at the output layer image get classified. So how the things going inside the convolutional neural network, let's understand that. So actually in the convolutional neural network, there are the two parts. Okay. First part is called as the feature extraction. Always remember, note it down guys, if you are having something to note down. Convolutional neural network working is divided into two major parts. First part is called as the feature extraction part, and the second part is called as the classification part. Note it down. First part is feature extraction, second part is the classification. So who is doing the feature extraction part? Very simple. As I told you, these are the three main layer of the convolutional layer. So the convolutional layer is responsible for extracting the important features from the images. That is a convolutional operation. Second, pooling layer is responsible for reducing the dimension of the image, and the third fully connected layer for classification. So let's understand that all the parts step by step. What is the meaning of convolutional actually? So I want to ask instead one question to all of you. Have you people learned convolutional mathematics in your study or not? In your graduation or anywhere? Just one simple question. No, you people haven't done convolutional operation. Okay, no worry about that. I will guide that. Okay. So the thing is that convolutional is nothing but one mathematical function or mathematical operation which is used for doing certain kind of mathematics. Just I'm going to guide you. Just wait. This is called as a convolutional operator. Please concentrate on this. Actually, image is nothing by guys two-dimensional function. Okay, image is nothing but two-dimensional light intensity function. One numbers are there in the images, pixels value. So on this image, please concentrate on the left hand side. There is one image, guys. There is one image, blue color. Okay. In this image, there are some numbers. This is called as the pixels number. Image is nothing but pixel representation, guys. Pixels is having number, and the pixel full form is picture element. So what we are doing that to this original image, which is highlighted in this slide by the blue color, we are applying one mask. So please understand carefully the meaning of mask is what, and different terminology used for this mask. So please note down, mask is also called as kernel, filter, feature detector, or feature extractor. 4 to 5 different names are there for this green color 3x3 mask in this image. Again, I am repeating, image is there in the convolutional neural network, which is highlighted in this diagram by blue color. Image is having pixels value, and we are applying one mask in that. So mask is also called as kernel, feature detector, filter, feature extractor. So in this mask, there are again some numbers are there. What is those number actually, and what those number represent? So please concentrate again very carefully. These numbers are nothing but researcher has analyzed something, and this number is going to extract some meaningful information from the images. Okay, this meaningful information from the images. So always remember, as when we are applying this mask to this image, so mathematical convolutional operation takes place. Convolutional operation nothing but dot product, guys, dot product. Concentrate carefully. So when I am going to apply this mask onto this original image 3x3, so whatever number of the mask and the number of image, that is called as the pixel value, is get multiplied. That is the convolutional dot product. And finally you will get one number, and that number is get replaced to the original image. So that is the meaning of convolutional operator. And just I want to show you with the help of some diagram again, so that you will easily understand that. Please concentrate carefully. Again, in the left hand side, original image of the size 5x5. 5x5 images is having some pixels value. To this original image of the size 5x5, I am applying one mask here. See, in the middle there is one mask, kernel, filter, feature detector, feature extractor, any name you can give. There is some number written inside the mask, 111, 000, -1, -1, -1. What is this number, and who is deciding that? So let me give the answer of that. This number we cannot decide randomly. This number is decided by so much research, because this filter number is nothing but extracting some meaningful information out of that. So guys, when I am applying this mask to the original image, so check it, my mask is of the size 3 by 3 and my original image of the size 5 by 5. So this 3 by 3 I am applying to the original image. So in the left hand side, see one highlighted 3 by 3 window you are observing. So the number inside this mask and the number inside the image pixel get multiplied. So check it, how it is get multiplied. This 7 get multiplied with the 1 plus 2 multiplied with the 0 plus 3 multiplied with the -1 plus 4 multiplied with 1 and so last 2 multiplied with -1. So we are going to do the sum of product, answer is coming 6. So we are going to give the answer 6 here on the right hand side, see here in this case. So the thing is that this 6 is called as feature map. Whatever the pixel number are there, it is called as a feature map. So now please note down in your notebook, in the convolutional neural network, first layer is called as convolutional layer followed by activation function called as ReLU. So what this layer is doing, concentrate, we are applying some filter to the original image. Filter is having some size, original is having some size. So the formula is telling that image multiplied by the filter is equal to feature map. Note it down guys, very important. Image multiplied by the filter is equal to feature map. And again, I am asking out of curiosity, what is the different name of mask? Can you tell me what are the different name of mask? Kernel, filter, feature extractor, feature detector. Okay. And when we are applying to this original filter, what is the output? Output is called as a feature map. And what is the feature map? Let me explain you the meaning of feature map and let me explain you what is the meaning of all this filter and the number. So as I told you, scientist has designed these filters guys. This number is not randomly decided. Let me clear you. This number came by doing so much research. And when I am applying this number convolutional operation to original image, so this number is extracting some information from the image. That is called as feature extraction. That is called as a feature extraction. And in this case, guys, again, please note down one important thing. In the convolutional neural network, that is first layer called as convolutional layer. Here are two hyperparameters. One hyperparameter is called as what is the filter size. Filter size we can decide. That's what I'm saying. Filter size is nothing but hyperparameter. And how many filters are available for this operation, that also we can decide. So please concentrate. In this image, although I'm showing the operation with the visualization for one filter on one image equal to feature map, but it doesn't mean that only one filter we are going to apply. We can apply 30 filters also. So we will get 30 feature map. For one filter, one feature map. So the thing is that guys, hyperparameter in the convolutional is size of filter and number of filter. Note it down. Size of filter and number of filter. Although in this image, I am showing the example of one filter applied on one image equal to one feature map. But in real world, we are applying multiple filters. For example, if in the same diagram, image is there on the left hand side, one image, but I am going to apply 30 filters. So how many feature map we will get? How many feature map we will get? 30. Very good. Now you got it. So one filters are used for extracting one information from the image. And then let's understand that what is that. Very simple now. So please concentrate. This is that. For example, in this image, concentrate carefully. Left hand side is one image, original image. To this left hand side original image of whatever the size of the image is, I will apply one vertical filter to this image. Vertical filter again, suppose 3 by 3 having some numbers in that. So that 3 by 3 vertical filter number is going to extract only vertical line from the original image. So check it on the right hand side, vertical edges. So what is happening guys behind the scene in the convolutional operation? You are extracting some meaningful information from the original image, and with the help of what? With the help of filters. With the help of filters. Now are you understanding or not? Tell me first. See, again I am repeating, original image is numbers, filter is a mask that is having some number. That number you are multiplying the original image, that after that multiplication it will extract some features from that. So the entire operation is called as convolutional layer operation. So the formula of the convolutional layer operation, understanding the formula means it is some equation. Image multiplied by the filter is equal to feature map. Image multiplied by filter is equal to feature map. And one more thing, please note down one more formula which I forgot to tell you, which is very important. In this slide, left hand side is one 5 by 5 image and some random numbers are there. We are multiplying to this 5 by 5 image 3 by 3 filter. So you are getting feature map is also 3 by 3. So how it is taking place? So note down the formula. Please note down the formula. Suppose the size of image is n by n, small n by n. The size of filter is f by f. So the output image you will get is, please note down, n minus f plus 1. Multiply by n minus f plus 1. I am writing in the chat window. Okay. I am writing in the chat window to everyone. The formula will be like this. N minus f plus 1. This will be the formula for feature map. What is the n? What is n? N means image size. What is f? What is f? F is filter size. And original out of this feature map size is what? N minus f plus 1. So please check according to this formula. 5 by 5 is the input image size. Multiply the 3 by 3 filter size. So 5 is small n, 3 is small f. So multiply, put in the formula. 5 multiply by 3 plus 1. What is the output? 3. So you are getting 3 by 3 feature map. You are getting 3 by 3 feature map. So I am writing in the chat window final formula for extracting the feature. Okay. Yes, Akshay, you are writing one more formula for having the stride and the padding also. I will come on that. Don't worry. Slowly I am teaching. So the final formula for the feature map is n minus f plus 1 according to this example right now. I will come for the further also. Okay, n minus f plus 1. Note it down. Multiply n minus f plus 1. This is the part. This is the feature map formula as per this example. Okay, note down. Very important and very easy also. So let's go ahead. So this convolutional neural network, first layer is convolutional, and we are working on how the convolutional is extracting the feature. Now please concentrate again on this example. 6 by 6 is the image size. 3 by 3 is the filter size. So what will be the feature map size? Tell me the answer. 4 by 4. Very good. Now you got it. Again, please concentrate carefully. The number inside the filters, who is deciding that? We are deciding, or it is a research part? It is a research. Research means researchers has already given some filters to you people, and that filter number is already decided. For example, search in the Google Sobel filter. So Sobel filter is having some number already. Okay. Sobel filter is having some number already. So check it. In the Google, you will get that. So please concentrate carefully. For example, in this original image, multiply this filter is equal to feature map. So the number inside this image is decided by researcher. You can also design your own filter, but that filter number should extract some meaningful information. Otherwise, randomly giving any number to filter, and that filter is nothing doing only mathematical operation and not extracting anything. So is there is use of any filter? Tell me logically. If I am giving any random number to filter number, and that filter number is multiplying with the original image and not giving any meaningful information, so there is no use of filter. So that's what I am saying. Researchers are designing n number of filters, doing n number of experiments, and finally they will come with such a number of filter which is extracting some meaningful information from that. So this is the convolutional layer operation, guys. And I hope you understood this. Yes or no? So check this in this slide, number of vertical filter and the number of horizontal filter. Check it just for the knowledge purpose. In this slide, other example are diagonal filter, color filter, edges filter, counter filter, and so on. So in this slide, there is a number. That number is detecting vertical edges. Horizontal mask is here on the right hand side. That number is detecting horizontal, and so on. This is called as, guys, filter operation. Yes, understood or not, tell me that. Then I am going for the other part. So now concentrate carefully. So once you will get this output as a feature map from the convolutional layer. Okay, so again we can apply pooling layer to the output of convolutional layer, that is to the feature map. Now understand this diagram. As I told you, entire convolutional neural network operation is divided into two major parts. First part is feature extraction, other part is called as classification. Who is extracting the feature? Actually, convolutional layer is extracting the feature with the help of that filter. Output is a feature map, that is called as a feature extractor. Feature is get extracted. Now to the output of convolutional layer, we are applying pooling layer. We are applying what? Pooling layer. Pooling layer is nothing but it is reducing the dimension of image. That's it. Hence, in this diagram, it is said that combination of convolutional and pooling is for use for feature extraction. And after that pooling layer, we are giving that 2D image converted to 1D, then it will become fully connected layer. And the moment it will become fully connected layer, from that moment it will go for classification part. So convolutional is this, guys, in the front of you. Classification plus feature extraction. If anyone asks you the question, who is doing the feature extraction? Originally, convolutional layer is doing the feature extraction and reducing the dimension of this feature extraction, pooling is doing. But feature extraction is only convolutional is doing. Okay. Hence, this is the meaning of that, guys. So the thing is that in the field of convolutional neural network, these are the important terminology. So why we are using the pooling layer? To reduce the dimension of feature map. Again, I am repeating, feature map. Okay. And what is the feature map? Output of convolutional operation. Understood now? Are you getting? Very easy. Okay. So now concentrate carefully. Very easy. That in the pooling layer, how many pooling operation is possible? Okay, how many pooling operation is possible? So let's take an example. Left hand side is the feature map. In this slide, there is the left hand side is the feature map of the size 4x4. Just example. And I am applying 2x2 pooling layer. I am applying 2x2 pooling layer. In this example, just consider the left hand side image is a feature map, output of convolutional layer. Again, I am repeating, output of convolutional layer is the feature map. To this feature map, suppose I am applying pooling layer of the size 2x2. So you tell me, in this image, I have applied 2x2 pooling layer to the original image, that is called as feature map. So there are 4 sections: green color, red color, and blue color, and some violet color. In the 2x2 pooling size into original image, green color, which is the highest pixel? Tell me that. Which is the highest pixel? 9. So see, in the output of pooling layer, 9 is there, 9. Why? Because I applied the max pooling layer, max pooling. Similarly, in the red color 2x2 window, which is the highest pixel, 2. So 2 is get forwarded. Again, in the violet section, 6 is the highest pixel, 6 is get forwarded. Again, in the bottom 2x2, 3 is get forwarded. So this maximum number pixel value is forwarded to the resultant image. This kind of process is called as max pooling because it is taking maximum pixel to the output. This is called as a max pooling. And what the max pooling is doing? Just check, simple answer. What is the size of feature map? 4x4. And what is the output of pooling? 2x2. So pooling layer is reducing the dimension of image. For that purpose, pooling layer is used. Just, and why we are reducing dimension? Any logical answer? Any logical answer? Please tell me. Suppose in the 4x4 image, how many total pixels are there? Very good. Akshay has given the answer. To reduce the computationals. Very good answer. That is the meaning of that. So not only max pooling, we are having so many options: average pooling, minimum pooling, and max pooling, and other customized pooling also according to our need. So max pooling is taking the maximum pixel value from the image. Minimum pooling is taking minimum value. Average pooling is taking average value. So this is the part of that. So the thing is that these are the entire part of feature map. Apply the pooling operation to the feature map. You will get the max pooling as the output, average pooling as the output, or sum pooling as the output. This is called as a pooling operation, guys. Okay. Now after that, in the field of convolutional neural network also, there is two major operation, or inside that we can say a stride operation also. Stride, what is the meaning of stride? Let's take an example. And what is the meaning of padding? That also take an example. In my previous all example, okay, for example, let me come here to the original convolutional operation so that you will understand the meaning of that. In this example, please concentrate carefully. Original image is of the size 5 by 5. Filter is the size of 3 by 3. When I put this 3 by 3 filter into my original image, so this blue color images get, we can say blue color is just highlighted, so that pixel is get selected. Now 6 number is the output of that after doing the multiplication of all filters value with the original image. If I will move the filter one step right side, so this will be the 3 by 3, next 3 by 3. Please concentrate on my cursor. 2 3 3 5 3 8 3 2 2. Just I have shifted one moment right. That is called as a stride, guys. What it is called as? Stride. Shifting your pixel value one moment right. So let's check it. Let's check it how it is shifting. See, again I am repeating, your 3 by 3 window is just shifting one step right side, and you are getting feature map as the output. So this filter, as it is moving the movement one step right side and then one step downside, movement of one is called as a stride of one. Is this clear? This is called as a stride of one. So if stride is coming into picture, so the size of output, that is called as a feature map formula, will become like this. So I am writing in the chat window actually the total main formula for feature map is this. Please concentrate. N minus f plus 2p divided by s and then plus 1. This is the major formula, final formula for feature map size. N minus f plus 2p. I have written is equal to, please correct the formula in the chat window. N minus f plus 2p divided by s plus 1. This is the formula. I will write in the slide also, don't worry. So this is called as the stride operation, guys. The moment stride is done, then again I am going for one more operation called as padding. So for what purpose padding is used? Concentrate carefully. Again, I will go to the same slide to explain the operation of padding so that you can easily understand. Please concentrate again this slide. Tell me, guys, in this slide, original image size is what? What is the original image size? 5 by 5. What is the resultant feature map size? 3 by 3 feature map. So actually original image is gets shrink to 3 by 3. So convolutional layer is also reducing the image size. Yes or no? I am not going for pooling right now. So convolutional layer is also reducing the image size. So 5 by 5 is reduced to 3 by 3. Image gets shrink. If I want that my convolutional operation should not reduce the image size, 5 by 5, apply the filter, output should be also 5 by 5. If I want this, then I will use padding. I will use padding, guys. Again I am repeating, to keep the size of image same in the convolutional operation, because convolutional operation is also doing the size reduction of the image. So for that purpose, we can use the padding also. So let's concentrate on that, how it will work. So padding is very easy. We are just adding the 0 layer at the corner pixels of original image like this. Check it. Original image is of the size 6 by 6. Okay, 6 by 6. And we are adding the 0 to the boundary of image. This is called padding of 0. What it is called as padding of 0. So if you are going with the padding of 0, then your filter size, your feature map will not reduce. Feature map will be the same size of input, guys. Feature map will be the same size of input. So just for the time limitation, I cannot go ahead for the detailed explanation of that. I am requesting that just take one 5 by 5 image, apply the 0 0 0 0 this padding layer to the 5 by 5 image, and apply 3 by 3 filter to that, and you check the output by your own. You will find that output is also 5 by 5. Hence size of the filter, size of the image is not reducing. So there are two kind of padding, guys. Two kind of padding. Okay, padding is used to for two purpose. As I said, to retain the size of image. Someone asked the question, to answer is to retain the original size of image plus to retain the information of boundary pixel. To retain the information of boundary pixel, padding is used. Okay, so don't worry. So padding is having two major applications, that is to retain the size of image and to retain the boundary of pixel. So the thing is that, guys, padding are of two types: valid padding and same padding. How many type paddings are available in the CNN? Valid padding and the same padding. Valid padding means no padding actually. We are not using padding there. And same padding means we are using the padding like this operation. So this is the example of same padding. In this slide, it is called as same padding. Same padding means add the layer of 0 at the boundary of the pixels. Same padding. And valid padding means no padding. So at the end of the day, this is the final formula of the image by considering padding and so on. So this is the example of padding, guys. Check it. In this example, I have added the valid padding to the 5x5 image. And then I have multiplied 3x3 filter. And when you will do entire operation, you will get output also 5x5. You will get output also 5x5. Is this clear? So this example which is available in this slide is called as same padding. What it is called as? Same padding. Are you getting or not? Please tell me. Although I know that I am going some little bit fast, but I want to know, are you getting or not? So in this slide, this is the example of same padding. For what purpose padding is used? To retain the image size. Again, I am repeating, to retain the original image size and the boundary pixel information. That is for padding is used. And at the end, guys, by having all consideration of padding and so on, okay, I am having the final formula available. This is that final formula. Okay, this one in this slide, please concentrate. Final formula of the feature map when I am considering padding, when I am considering stride and so on, this is the final formula. Okay, this is the feature map, guys. This is the convolutional layer operations. So convolutional layer, in order to understand, convolutional layer is having the two major thing. One is called as the filters and the size of filters and total number of filters, that I call as a filters. So if anyone asks you in the convolutional operation, what are the hyperparameters? What will be your answers? Tell me. What will be? Yeah, size of filter, number of filter, stride and padding also. Yes or no? Now this is final convolutional. I haven't went to pooling yet. Again, I am repeating, only in the convolutional operation, how many things possible? Again, I am repeating, number of filter, size of filter, stride and the padding. Yes or no? All are hyperparameters and very easy. So I can decide how many filter I can use. I can decide the size of the filter. I can decide, shall I use the padding or not? I can decide what should be the stride, 1, 2 or what. And these four major thing is the key step for designing convolutional layer. Now I hope you understood the meaning of convolutional layer. Then output of convolutional, we are applying pooling. So now second layer will come into picture, pooling. Are you getting now? Yes, respond. So write down in the sequence. First is convolutional. In the convolutional, four major part: size of the filter, total number of filter, stride and padding. Very good. Then output of this, we are going for, we can say, pooling layer. Pooling layer is reducing the size of image, that is size of feature map. And output of the pooling, we are feeding to the fully connected layer. So at the end of the day, you are having the final structure available in front of you. That is called as the world of convolutional neural network. Check it now in this diagram. Check it in this diagram. What we are doing, original image. I am applying convolutional layer. Inside convolutional layer, four things are coming: size of filter, total number of filter, stride, pooling. Output of convolutional layer is feature map. Apply pooling layer. Pooling layer is reducing the size of feature map to half. Again, output I can apply one more convolutional layer because this is the hidden layer architecture now. I can put n number of convolutional layer. It is up to me. And n number of pooling layer. It is up to me. That's what you are a designer of your own convolutional layer. Okay, you are the designer of your own convolutional layer. Okay, so the thing is that in this architecture, please concentrate carefully. I am asking one question, logical question to you. How many convolutional pooling layer used in this architecture? Tell me that. Very good. Two stack of convolutional pooling is used in this architecture. Now the same architecture I can design in such a way. Please concentrate. Convolutional layer. Again after that pooling layer. Then convolutional layer, pooling layer. I can do like this also. It doesn't mean that after the convolutional layer compulsory always pooling layer you need to apply. You can do one thing also, convolutional layer, again convolutional layer. Then after that pooling layer. Then again convolutional layer, pooling layer, convolutional layer, pooling layer. You are a designer of your own. Is this clear? But blindly we are not doing all this, guys. We are doing all this designing related to problem statement and the domain knowledge. So then you are using how many convolutional layers should I use? Shall I apply pooling or not? Shall I apply any other process in the architecture or not? So you cannot doing that blindly. You are doing something with the help of some previous knowledge. Is this clear or not? So now one again logical question. The combination of convolutional and pooling layer is giving what information to you people? Is giving what information? In this slide, it is the features. Very good, Pallavi. I appreciate you. Features. That is called as the important feature. Now again, one logical question inside that. Who is actually responsible for extracting the features? Who is responsible for extracting the feature from the original image? Filters. I really appreciate Tagoreji. Your answer is correct. Filter. Actually convolutional layer, but inside convolutional layer filter at the end of the day. Yes or no? In the convolutional layer only filters are there. So main thing is filter. Filters are used to extract the important features from the data. And then you are going ahead for that. At the end of convolutional pooling operation, we are getting the important features. So that important features now we are converting to one dimensional, that is called as fully connected, and then it is going for the classification part. So fully connected layer is responsible for classification. And no, I have not frozen the screen. Actually, I'm stuck in this screen only. Don't take tension. So the thing is that convolutional pooling layer used for feature extraction. That feature extraction, whatever we are doing is converted to one dimension. Sorry, one dimension, and then it is connected to fully connected part, which is doing the classification part. This is the world of convolutional neural network. And I would like to show something to you. I have already shared one Jupyter notebook with you. I hope you are having that Jupyter notebook with you. Okay, open that Jupyter notebook. I will explain you something. Okay, so the thing is that again I'm requesting the organizer, please give me one more session to explain convolutional neural operation on color image. I have explained today convolutional neural operation on one channel, that is called as a grayscale image. Okay, I am requesting give me one more session for color image also. So guys, whatever I have explained today is by considering for what purpose? Which part? Grayscale image. Okay, and so on. Color image I will explain you after this session actually. Okay, because in this session due to time limitation is not possible. So guys, please go and open the Jupyter notebook which I have shared with you people, and the Jupyter notebook is this one, ANN versus CNN for image classification. Please go ahead, open that. You can search my name in LinkedIn with the name called as Arpit Yadav, Senior Data Scientist at Upgrade INSOFE. Yeah, you can plan master class also for 3 hours. If suppose analytics Vidya is ready to give me 3 hours, I will do entire postmortem of this. Ask Analytics Vidya. Ask them. I don't know that organizer are listening or not. Please open this. You only people request to organizers, okay? Then they will give you 3 hours. Then 3 hours means end time postmortem research work for CNN. Don't worry. So please open this and write down in the chat window. I hope you are understanding. Although I have gone little bit fast, but I assume that you are understanding in the clear way. So if you open this, I am going to explain one project. That project I am going to logically prove you that how CNN is better than ANN for the same project. For the same project. Okay, so please concentrate carefully. What is this session about? Okay. Yeah, I can able to help anyone. Don't worry. Just connect with me in LinkedIn. Priyanka Darbari, connect with me in LinkedIn. Okay, don't worry. I will help you out. So this project is that we are going to do image classification. We are going to do the image classification of handwritten digit data set with the help of ANN and CNN. Okay, VNN and CNN. So in the ANN and CNN, I am going to prove you that CNN is the better architecture for image classification because data is of image. Now please concentrate carefully. What is this project about? This project tells us that we are having, now please concentrate, I am writing here so that you can understand. We are having 70,000 images, 70,000 images of handwritten digit 28 by 28 grayscale image, and we are having 70,000 label associated with that. This is the data set description I am showing. We are having 70,000 images as an input and 70,000 label as output. All the images is of the size 28 by 28 grayscale image. This is the data set given to us. So 70,000 images with 70,000 label. Which are those images? Handwritten digit image of the size 28 by 28 and grayscale image. Now we have to design image classification ANN and CNN architecture to classify this image. So how many digits are there, guys? How many digits are there? This is the MNIST data set. Absolutely correct. Open source data. How many digits are there? Tell me. 0 to 9 total 10 digits. So we have to design ANN architecture and CNN architecture to classify 10 digits. So this is the problem of multi-class classification. What is this problem about? Multi-class classification, because I have to classify 10 digits. Okay. Now, I'm just going and wrapping the session. No worry. So say this is the project. So this is the multi-class classification project. So what I am going to do, guys, you are having the Jupyter notebook with you. Just import all the necessary packages which is required to design the architecture. For example, TensorFlow, Keras, Matplotlib library for data visualization, and all these layers, modules, and so on. So we are importing the necessary packages for designing the architecture, that is ANN and CNN. Now please run this parallelly along with me, those who are having this Jupyter notebook. My voice is breaking for everyone or only for Sandhya? My voice is audible or not? Please let me know. Voice is breaking for everyone. Okay. Sagar, my voice is clear.
Now it's clear. You can, like, in starting it was breaking, but now it's clear.
Okay, everyone. Okay. Now it's clear.
Yeah, now it's clear. You can continue.
Okay. Thank you very much.
It's breaking again.
Yeah, your voice is not audible to me.
I think it's breaking again.
Okay. Again, I am repeating. My voice is clearly audible.
Yeah, now it is.
Okay.
Arpit, you there? Arpit? Just a minute, Arpit is here. I think he's reconnecting. So
No, voice is clearly audible.
Arpit, your voice is
Please,
breaking very much.
or Mhm. Voice is clear.
No, it's breaking.
Okay. Just give me. Okay, can you please again tell me my voice is clearly audible now? Am I audible, guys? Hello.
yes, Arpit, your voice is audible.
Oh, now, please just give me 5 more minutes, Sagar. Okay, just 5 more minutes. I will not take more than that so that I can explain this to them. Okay. So please concentrate carefully, everyone. Due to time limitation, I cannot go in detail. Just request the organizer provide more time in future. So what is this project about, guys? Actually, in this project, I have explained we have designed the CNN and ANN architecture for multi-class image classification problem. And this is all data set we have imported from Keras. It is automatically divided into training and testing part. 60,000 images going for training, 10,000 images going for testing, and just we are doing some basic data exploration part. And guys, what we did in this project, we have designed this ANN. This is called as ANN, not CNN. This is fully connected layer. In this architecture, there is one hidden layer of 100 neuron. So input neuron is having 784 neuron connected to 100 hidden layer. Then it is connected to 10, sorry, it is connected to one hidden layer of 100 neuron, and it is connected to output layer of 10 neuron. This is ANN. With this architecture of ANN, when we go for the model training, we got for 10 epochs, last epoch 99% accuracy. For the last epoch, 10th number epoch. Okay. For the same project guide, this is now CNN. Please concentrate, guys. This is CNN here. CNN required how many, which data CNN required, guys? Please tell me. Please tell me today I taught you CNN layer. For only CNN layer, what we want? Filters, filter size, stride, and padding. Yes or no? These four things we required for convolutional. So concentrate carefully here. In this line of Jupyter notebook, this is the convolutional layer designing. This convolutional layer, this 30 is nothing but 30 number of filters. Concentrate. I can give here 60 also, I can give here 100 also, 64 also. It is up to us. This 3 by 3 is nothing but kernel size. That is called as filter size. Concentrate. Very easy, guys. Don't fear about coding. Very easy. So 3 by 3 is the kernel size, because as I told you today, convolutional layer want kernel size, number of kernel that I have given. In the same line at the end, I can write down comma, padding equal to same, like this. Padding equal to valid or same, like this. I can write down like this also. So if I am not writing any padding here, for example, so by default it will take valid padding. Valid padding means no padding, and activation is ReLU. So this is called as designing of convolutional layer. And to this first convolutional layer, we are giving the input 28 by 28, because data set is of 28 by 28. Are you getting now? This one is called as one image is at a time coming to this. Okay, fourth dimension. And now this is called as a convolutional layer operation. And now take it, input to this convolutional is original image of 28 by 28. Okay, concentrate carefully my question. Okay, input to this convolutional is coming 28 by 28. So in the first convolutional layer, how much size we are applying? Filter size 3 by 3. So what will be the output of feature map? 28 by 28. 3 by 3 is the feature, that is called as feature detector. What is the output? 26 by 26. So check it here, 26 by 26. In this model summary, output of first convolutional layer is 26 by 26. And I told you, one filter into original image, one feature map. If I will apply 30 filter to the original image, how many feature map? 30 feature map. So check it here in the first line, concentrate. 30 feature map, sorry, 30 filters, 3 by 3 to the 28 by 28. So check in model summary, I will get feature size of 26 by 26 and 30 feature map. Now this is called as convolutional layer, guys. Now are you understanding logically also? See here, mathematically also I am explaining everything, and very simple also. Immediately to the output of convolutional layer, that is 26 by 26 image, I am applying max pooling of 2 by 2. So I am asking to pooling layer, hey, reduce the convolutional output to half, because max pooling is 2 by 2. So output of convolutional is 26 by 26 by 30. Apply max pooling. Output of max pooling will be 13 by 13 by 30. So check it. Output of max pooling here, 13 by 13 by 30. Are you getting now? Okay, very easy. Is this hard or easy? Okay, again I am repeating convolutional operation. This is the convolutional designing we are doing. This is the first line is of convolutional layer, and I taught you that in the first line of convolutional we are having 4 information: number of filter, size of filter, stride and padding. Stride and padding. 30 means 30 filters I am applying, 30 different filters: horizontal filter, vertical filter, diagonal filter, edge detector, color filter, and so on. This 3 by 3 you can change to 5 by 5 also, 7 by 7 also, it is up to you. Instead of 30, I can write down 90 also, because these are hyperparameter. Okay. If I will not apply this one, guys, okay, any padding information and stride, by default it will take valid padding. Valid padding means no padding. Sorry, padding is there. So in this, again I am repeating, sorry, please concentrate. Padding, if I am not applying, what is the padding used for here? So by default, it will consider valid padding. Okay, valid padding. Same padding means we are applying the padding actually. So please, okay, I am concluding the presentation as per the organizer decision. So I hope that you people are understanding in the clear and crystal way that 30 number of filters, filter size 3 by 3, padding and the stride in the convolutional layer. And in this output is softmax. Yes, guys, there is no sigmoid here. It should be softmax. Now these two in this layer. Now please say me last question. I am asking, in this convolutional layer designing, how many convolutional pooling layer I have used? 1. So I can do one thing also in front of you. I can copy this. See here, I am copying this, and I can write down here Control V also. Now second architecture design in front of you within 1 second. What I did, convolutional pooling. Now again I have added convolutional pooling. Again, if you want your own architecture, copy this. Again at the end of this, again Control V. Again this is your other architecture. So here I am using 3 stack of convolutional pooling, convolutional pooling, convolutional pooling. Is this clear? Okay guys, so please go ahead of checking this Jupyter notebook, and you will find that in this Jupyter notebook I have applied 5 epoch to convolutional layer, and at the end of 5 epoch only I got 99% accuracy. So convolutional layer is beating ANN at the epoch 5 only. No need to go for 10 epoch. No need to go for 10 epoch. Pallavi, for the parameter calculation and all, I need a time, but due to time limitation, I cannot go ahead. But in the next session, I will meet. No worry. I request the organizer to just give me the next session also, so that I can explain in detail to them. So thank you very much, guys. And that's all from my end. Due to the time limitation, I cannot able to go ahead. And soon we will meet. Okay. Just Sagar, provide me one more what I can say session, because participant want to learn that. And thank you very much, guys. I hope that you understood majority concept. Although I understand I went fast, okay, and such a high level concept within 1.5 hours is very difficult. Thank you very much. Whatever I explained, I tried my best.
Like, this was a great session, and I think participants have enjoyed much more. I can see in chat section. We'll get back to you for another session.
Yeah,
so
yeah.
don't worry about that.
Sagar, one thing I just want that does every time we are having limitation for 1 hour, or can we go for 3 hours also?
I'll need to check it with my seniors too, because this session was an hour session we started.
Okay.
So
Okay.
we need to see as
Because
if it's possible
participant is demanding
the 3 hour session,
3 hours.
that
Yeah.
will be get back by the editor side.
Yeah. And all the participant, you can connect me in the LinkedIn by the name Arpit Yadav, and designation is senior data scientist. Okay.
We'll share the Arpit's link, LinkedIn profile. You can follow him there. Sagar, if you are there, please share the link for Arpit's profile, or I'll just share it with my side. So
please share that. Okay, so that participant can connect for their doubt, and I can I will be very happy to solve their doubt.
Arpit, you can take questions in Q&A section.
Yeah. In the Q&A section, is the computer vision is the field of data science? Yes. Computer vision is the part of data science world, because obviously we need the data in the computer vision in terms of images and video. In terms of images and video. Okay. And other question, Swati Pandey, my profile is locked. I was not able to say. You just send me connect request, Swati, connect request, so that I can able to take that. Yes, we can use CNN in quantum computing also, but depends on what kind of problem statement we are solving there. Quantum computing is a very recent field. What can we get resources to do large computation? Example, computers like GPU for free. Okay, you can go for actually computer system with the GPU processors. If you are not having that, use the cloud computing called AWS, Amazon Web Service, and so on. Can we say filter is trend weighted filter? Dinesh, yes, that is whatever filters we are applying right now. It is given by the researcher, those values are fixed. If you want to design your own, it takes lots of time. I am not saying that we cannot design. Yeah, we can design that. What are the different other question? How to decide filter value? As I said, filter value we can decide by n number of research process. Can in pooling layer losing the information, because in max pooling we are ignoring? No, we will not able to lose any information. Instead, we are retaining the maximum information from the max pooling operation. Does the kernel always to be 3 by 3? No, kernel size should be 3 by 3, 5 by 5, 7 by 7, depending on our need. Why do we use several convolutional layer? Because for the complex problems, in the complex problem statement, we are using several convolutional layer to extract the features. Initial level of convolutional layer extracting the basic features information, and the further level of convolutional layer is exactly extracting the problem statement kind of features. Pooling layer, what is the difference between pooling and flatten? Pooling layer is used to reduce the dimension. Flattening layer is used to convert 2D to 1D, two-dimensional to one-dimensional. What all pre-processing is mandatory for image in CNN? You should have all the images is of same size. You can do the normalization of the images. N number of image processing you can do in that, Ritesh. Number of hidden layer is also hyperparameter. Yes, number of hidden layers are hyperparameter. Transfer learning means what? As I told you at the starting, there is one competition called as ImageNet, and that ImageNet competition has been organized for multi-class classification for 1000 category. The winners of that competition, that architecture is declared as a transfer learning architecture, state of art architecture. That is a transfer learning. We are using the predefined architecture for our problem statement, which is matched with the transfer learning problem statement. Is this clear, everyone? So thanks everyone. I hope that your doubt has been resolved. If not, please connect with me in LinkedIn. I will be happy to provide you more time to clear your doubts. Any
Thank you,
more?
Arpit, for this lovely session.
Yeah. Thanks,
We really
Sagar.
enjoyed it.
Thanks. I also enjoyed with interacting with the
Nishant.
participants. Hello.
It's Nishant.
Okay, Nishant. Oh, yeah. Sorry, Nishant. I just
Fine.
misconfused. Okay, so Nishant, thank you for coordinating this, and just provide me a few more session in future. Okay.
Okay, we'll get back to you regarding that.
Sure. So nice to interact with all the participants. Thank you very much, guys. I really enjoyed a lot by interacting with you. Thank you very much. Any question? I'm waiting again. Let me know.
So we have shared the Arpit's LinkedIn profile in the chat section. I'll share it again, and you can go there and raise your questions and follow him on LinkedIn.